Just as we had common rhetorical fallacies that we saw just at the level of looking at the story, and we had some common deductive fallacies that we saw at the level of the form of the argument, there are also some common inductive fallacies. Let's have a look at a couple of examples. Suppose we make the argument, English teachers are all mean. I've had mean teachers in both of my last 2 English classes. So, in this argument, English teachers are all mean is the conclusion that we're trying to draw. And the premise we want to base that on is that we've had mean teachers in both of our last 2 classes. This argument exhibits an inductive fallacy called hasty generalization. A hasty generalization concludes that all or most of the members of a group have some property based on observing a very small number of members. Notice that this is a little bit hazy. Just what does it mean to have a small number of members of a group observed anyway? But I think that we can agree that 2 is a small number. If you have 2 mean English teachers, that's probably not a sign that all of them are mean. Okay, so hasty generalization is one common inductive fallacy, coming to a very broad conclusion based on a very small number of observations. Here's another example. In a TV commercial, a car insurance company lists the amounts that customers have saved by switching to their car insurance as $510, $475, $490, and $535. They want you to come to the conclusion that if you switch to their car insurance, you will also save hundreds of dollars. So the conclusion they want you to draw is that if you switch to their car insurance, you will save hundreds of dollars. And the premise they want you to believe this from is that customers that have switched, well, they've saved all these different amounts of hundreds of dollars. Now, I don't have access to the car insurance company's database, but I'm inclined to believe that this is an example of an inductive fallacy called cherry-picking. An inductive argument is using cherry-picking when it selects the specific observations, and it selects those observations in order to support a conclusion that it wants. The argument wouldn't support the conclusion as well if it included just kind of a random bunch of examples. In the TV car insurance commercial, there are 2 things going on. Probably people who looked at that car insurance and discovered their rates would be higher, they probably didn't switch. And if they did switch, they almost certainly wouldn't be mentioned in the commercial. There are all sorts of commercials like that where you see a little caption at the bottom of the screen that says, "Results not typical." Those are all examples of cherry picking. They all want you to draw an inductive conclusion based on very carefully selected individual observations. Okay, this last one is surprisingly common, and it becomes hard to spot because when we're explaining what it is, we pick ridiculous examples. A politician notices that people who own horses are significantly less likely to be homeless than people who don't own horses. So he proposes a policy to give away free horses to reduce homelessness. The politician has drawn the conclusion that having a horse prevents someone from being homeless. An inductive argument is using faulty causation. When the conclusion states that one factor causes another, without additional evidence, without enough evidence to support saying that one factor causes another. So usually what's going on is something like what's happening in this example. In this example, probably what's going on is that, horses are expensive and homes are expensive. And if you can't afford a home, you probably also can't afford a horse. Giving you a horse, making it easier for you to afford a horse, won't actually make it easier for you to afford a home. So that's not going to help with the homelessness. Now, when you're making inductive arguments, showing that one thing causes another is actually extremely challenging. And the kind of argument that you need to make in order to show that something is actually causing something else is well outside the scope of this class. But whenever you see an inductive argument that claims that one thing causes another, be sure to look at it and see if there's anything to rule out, say, the causation going the other way, or the two things sharing a cause, or even just a pure coincidence, because sometimes there are also pure coincidences.